Welcome viewers to the SD online classes. Here today we are going to do class 10 science, specifically physics, Mizoram Board of School Education, chapter 1, light reflection and refraction, page number 3, because page number 1 and 2 introduction I already gave you, and the whiteboard projector proper lecture. There we have introduced all the things required earlier up to convex and concave, just introduction. Okay, it took long. After that I moved for maths classes. Now I want to continue the second episode of this chapter. Okay, here the things that we are going to learn today are some important. You can see your page number 3 of your textbook. So this is the one, some important terms related to spherical mirrors. Spherical, you already in the previous video, you know, spherical mirrors means the concave and the convex. Okay, now in every convex and a concave mirror you will have some of the special things that you need to know. What are they? Number 1, aperture. What is aperture? Let's see. It is the width of the mirror from which reflection can take place is called its aperture. Basically it is the size of the mirror. Okay, aperture is the size of the mirror. In the lens also it is very popular. When you go for a camera to buy a camera and all, you will see the aperture will be there. Okay, it is the actual distance, which is in your textbook. You can see there is a figure given 1.2. there you will find it is that mm. Can you see mm? That means if suppose you have the mirror like this is a concave mirror, that means starts from here and up to here. Remember, this type of mirrors are just like a plate. Okay, just like this type of plate. Not, don't think it is a thin wire. This is not like this, but it is like this. Okay, this is the mirror light will be like this, not like you will be having a simple thin wire. Okay, so this is the size from where light can come and the portion where it can hit and it can bounce back, right? This is the aperture. So how do we write this? We write it is given in the textbook also. This is the one. This is the one. You see the width of the mirror. Okay, size actually it is this width of the mirror from which reflection can take place, where you can hit the light and come back. So that is called your aperture. Now clear? Now the second topic will be the pole. Let's see what is this pole. So pole is the, let me draw in the diagram and tell you. Let's see here, pole is this point. Okay, if there is this mirror, size of the mirror is mm, already I told you aperture, its midpoint here exactly at the middle, there is the pole. Pole is important because from there we take all the measurements. Okay, and in the previous aperture also I gave you only example from concave. This will be the convex. If the convex aperture is there, that means this is a concave mirror, this is convex mirror. Okay, similarly even the pole also like that, for concave also, for convex also it will be like that. Okay, now there is the third one, which is center of. Now let us see here again. Center of curvature is denoted by capital C. Okay, what is that? If you have a mirror, suppose the mirror is mm dash as usual, pole is here P, and if this is a part of big ball, okay, the sphere means a ball like this, a football like, hollow, inside nothing there, and then you cut that piece like this, right? This part is the mirror. If you connect the whole part, again the full part, that will be your sphere, just like a ball, and its center will be called center of curvature. So one very important thing is that the center of curvature is not exactly inside the mirror. Okay, the mirror does not contain this. If you take the mirror here and there, the mirror will contain the aperture, mirror will have the pole, but the mirror inside that you cannot point and show here is the center, here is the center. It will be also always outside here. Okay, this is very important. And where it is for concave, if this is a concave mirror, behind, this is the front side, okay, front means this side. And in case of your convex mirror, suppose this is your convex mirror and this will be your pole, this will be your M and M dash, then where is the center? You make the whole sphere complete. Sphere will look like a circle because in the paper you cannot make a sphere properly. So here will be the center. You see, therefore convex, this center of curvature is behind. It is the part of that big sphere for which the center is this one. So these are the three things inside it. We'll continue further. The next thing that you need in a spherical mirror, that means either it is concave or convex, doesn't matter, will be radius of curvature. Remember, recall, the first one is aperture, second one is pole P, the third one is center of curvature, the fourth one is radius of curvature. Once you know all these things one by one, you will recognize as mirror as soon as you see what it is of type and what are the things inside it, okay. So the fourth one is radius of curvature of a mirror. Now you see what is radius of curvature. The radius of hollow sphere, that sphere we were talking about in the center of curvature in the previous one, same, it is connected to that hollow sphere of which the reflecting surface of a spherical mirror forms a part. Suppose this is that hollow sphere, then this is the center of curvature, then you will have the radius. That radius is called, that radius will be called radius of curvature, this distance, okay, from here to here. Its name is radius of curvature. Those are points. This M is the aperture, P is a point, pole, C is also a point, C, and radius is a distance, okay. That is the distance, just like radius of a sphere, nothing else. Now for a concave it will look like this. For convex, I think you can guess easily what it looks like. If this is a convex, you will have M dash. It is a part of a big sphere like this. Its center will be somewhere here, right. This will be your pole and this is the radius, okay. So this is how you can show in both of them. This is the radius of curvature, and it is the radius of curvature is nothing but r equal to what? The distance is PC. PC. Here also r equal to PC. Radius of curvature is that PC distance. The next will be your principal axis. Principal means main, you can easily understand. So axis means that main line. Where is the main line? You can understand where it is when you see the mirror. Now you see, principal axis is this line, not the radius, okay, this line, the imaginary line. So imaginary means it is not actual line, it is just we imagine it is there, okay. The imaginary straight line joining the pole, joining this pole and the center of curvature, this line joining, and it is extended like this, okay. So this is in case I made the concave first, convex first this time. Every time I was making the concave first. This time I made the convex first. Okay, in the concave, you see this line. This is the sphere. The drawing is not very good, but I had to accommodate here. So x, y, this long line inside which the radius is also there. Okay, so this is principal axis. Pole, center, everything it is connecting. Here also pole, center, everything it is connecting. Okay, so this is your what you call principal axis, and the main axis in the right at the middle of the mirror you can see that. And one very important small thing you should remember here is it is xy in this case. Okay, here it is xy means principal axis is normal. Normal means perpendicular, normal to the mirror at the pole. Exactly at the pole you go here. Here you see, you will find it like this. Here it is 90 degree. Okay, here it is making 90 degree. Exactly at the pole this line makes 90 degree. Okay, so this is how you can see these parts. The next will be normal. What is normal? In the diagram I will show you. Look look at here, what is the normal? Normal means usually perpendicular, but where? Let's see, the line joining the point of incidence. What is point of incidence? Where incident light comes. Incident light means the light which is coming from the starting point. Light will come and hit the mirror, and from that point, wherever it hits, from there, if you see the center of curvature with dotted line, okay, like this. Suppose that hitting point is D, okay. So this DC will be called normal. Why normal? Because here it is making 90 degree, okay. It is a tangent with the radius like property in the circle, okay. So this is the for the concave mirror, and for the convex mirror also it is possible. In the convex mirror, suppose this is X, Y, this is pole. I should have made it in the middle, but it's okay. The light is going like this, and it will be reflected back here, okay. That will not draw later on, you will draw in the other diagrams. From here it is D, so this will be your center C. So this DC is your normal line. It is believed it is the perpendicular line, okay. So now this is the introduction for your normal line. Till now what you have done, remember, aperture, pole, then radius of curvature, center of curvature, and normal, and what more, one more is there, center of curvature, principal axis also, okay.